In examples 4 and 5, we are asked to find when the particle is speeding up and when the particle is slowing down. And so this is definitely going to have something to do with acceleration. And one of the things that I like to do for problems that ask about speeding up and slowing down is I like to, first of all, go through and divide my graph up into intervals where the velocity is changing. We'll just mark each integer on our number line. And so here, I'm going to look at velocity, and I just want to know where is the velocity positive and where is the velocity negative. So on the first interval from 0 to 1, we're above the x-axis, and so the velocity is positive. And again, between 1 and 2, we're above the x-axis, so positive. Between 2 and 3, we drop below the x-axis, and so our velocity is negative. And in fact, it remains negative for the remainder of the graph. Now, the next thing that I want to do is think about what's going on with the acceleration. And so remember that what I'm going to be looking at here is the slope of the line. And again, I'm interested in when is it positive and when is it negative. Now, on this first interval from 0 to 1, I actually have a 0 slope, so it's neither positive nor negative. But between 1 and 2, I have a negative slope or negative acceleration. Between 2 and 3, we again have a negative slope or negative acceleration. But then beginning at 3, we have a positive slope, and that continues to the interval between 4 and 5. Now, the reason that I like to do this is because the particle or object or whatever is going to be speeding up when the signs are the same. And if you think about it, that makes sense. If I have a positive velocity and a positive acceleration, I'm going to be speeding up. And what's a little maybe weird to think about is having a negative velocity and a negative acceleration, and that also be speeding up. But you can think of it as maybe a rock in free fall where you're falling in a negative direction, and gravity is also acting in that same negative direction. And so they are reinforcing each other. Now, the other possibility is this. The signs are different. And when that happens, it's slowing down. And the reason is because the acceleration and the velocity are at that point acting in opposition to each other. So I think I've got enough information to answer this question. So the first one was, when is it speeding up? So I'm going to go through and I want to look at each interval and see where are the signs the same. Well, they're the same between 2 and 3. So let's make a note that we're looking for the same signs. And that happens when 2 is less than t is less than 3. Now let's look at question 5. When is it slowing down? It slows down when we have opposite signs. And so positive velocity, negative acceleration, so between 1 and 2. And then it happens again between 3 and 4 and 4 and 5. So we've got these opposite signs. And since this is continuous across 4, let's just make that one interval. So we'll say between 1 and 2 and between 3 and 5. And of course, that's going to be when we have different signs. All right.